Hi, class. Let's take a look at our very last section of uh, muscle physiology. And I think I mentioned this in an earlier video, the difference between hypertrophy and atrophy. So when a person is exercising, your muscles can increase in thickness, increase in size. So muscle growth from heavy training and usage, that's hypertrophy. When we have the lack of muscle activity and there's reduced muscle size, tone, and power, that's muscle atrophy. That's the big difference. Between the ages of 30 and 50, about 10% of the muscle tissue is replaced by fibrous connective tissue and fat. Between the ages of 50 and 80, another 40% of muscle tissue is replaced. The consequences of that are that muscle strength and flexibility decrease, reflexes are going to decrease, and the slow oxidative muscle fibers are going to increase. When we look at people, part of my initial exam, when I shake a person's hand, I turn it over, I like to look not just at the nails, and I like to look at muscle tone. So these are tendons right here. This is a tendon, this is a tendon, this is a tendon, and these are tendons. These tendons are superficial to the bone. And in between, this is where we have lots of muscle. We have muscle in here. And when we look at the hand and we look at the knuckles, right, you're going to see like this, a little bit of this, but we don't want to see too much of this. We don't want to see too, like the hills and the valleys, the knuckles or the hills. When we look at the valleys, we don't want to see deep, deep valleys because that means that the muscles are wasting away. When muscles are wasting away, remember the sarcomere? We have a condition called sarcopenia. Sarcopenia happens as people age and their body starts to break down their own protein for energy. We don't want that to happen. And that's why protein in the diet is so very important, but not just putting in protein. We need to make sure that we have the proper digestive enzymes in the stomach to break them down. When we don't have enough enzymes to break them down, that's when people eat and their bellies get all puffy and they get like all swollen and they go, I got to undo my button, right? They don't have enough digestive enzymes to break down the protein. So it's not you are what you eat, it's you are what you can digest and break down and assimilate. And we need digestive enzymes to do that. We want to make sure that we have good hydrochloric acid in the stomach. But think of how many people get heartburn and use antacids. When they use antacids like Tums, right? What they're doing is they're decreasing the hydrochloric acid. If you don't have hydrochloric acid, you cannot break down protein. So a lot of people are doing harm to themselves by self-medicating and using these antacids for a little bit of heartburn, which has also negative impact. With antacids, not only can't you make hydrochloric acid, but you decrease your iron, you decrease B12. These can all lead to anemia, fatigue, and anemia. So you have to be really, really, really careful. And when you decrease hydrochloric acid in the stomach, hydrochloric acid is what we call bactericidal, meaning it kills bad bacteria in the stomach. If you don't have hydrochloric acid, you can get bacterial overgrowth in the stomach. Nothing keeps it in check. So hydrochloric acid, very, very important. You also want to be careful of people when they drink pH water, especially if the pH is too high. pH water is detrimental to the stomach. It's a big fad. A lot of people do it. But if you drink alkaline water, that is the same thing as using antacids. Because remember, on a pH scale of 0 to 14, and 7 is in the middle, which is neutral, 0 to 7 is an acid, 7 to 14 is a base or an alkaline, and your stomach pH has to be here at 2.3. When you drink pH water of 10, 11, 12, you're putting uh, alkaline or basic liquid directly into the stomach, and you take the pH of the stomach and you raise it. That's all you're doing. And when you do that, you decrease the effect of hydrochloric acid. If you decrease acid in the stomach, you can't break down your protein. If you decrease the acid in the stomach, you can't absorb iron, you can't absorb B12, and you can't absorb calcium. Oh boy, bad, bad stuff, right? So to assess muscle strength of the hand, there's an instrument called a dynamometer, and the patient would squeeze this instrument. There's a needle, the needle moves up, and then there's like a marker needle that when you release, the large needle goes back to 0, but if you squeezed it to 80 or 90 pounds of crushing force, the needle remains in the highest pressure, the highest pounds of crushing force that you were able to squeeze with, so that you can read and look at the strength. You compare the right hand to the left hand. It's called a dynamometer. These should be pretty strong in people. If you have decreased muscle strength, it's not good for longevity, especially as people get older. You don't want sarcopenia of the thigh muscles, the leg muscles. We need the elderly to be able to sit on a toilet by themselves, get off the toilet by themselves. So part of my examination, when I look at my patients in my waiting room, I look to see if they can lift themselves up off the chair by just using the strength of their legs, or do they push with their hands on the armrests to stand up? If they use the arm rest, it shows me that their thighs and their leg muscles are weaker. If they could just stand up without using the arm rest, much, much better for the individual.